Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now an oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So the neither of the front as well as the top view projections of the oblique line, they will be parallel to the XY reference line, and we are going to obtain the projections of the oblique line onto horizontal plane and the vertical plane as an apparent length. And because of the inclinations of the oblique line with respect to HP and VP, so we are not going to obtain the true length of the line either in the front view projections or in the top view projections of the line. And due to the inclination of this oblique line with respect to both the horizontal plane as well as the vertical plane, we are going to obtain both the horizontal trace as well as the vertical trace. And another thing we need to remember that the traces, they should be obtained through the projection lines A dash, B dash and AB. And we must remember that traces, they are never obtained through the true lengths of the line. They will be obtained only through the projections of the line in the front view as well as the top view projections over there. Now let us read out the statement. So here we have been provided with a straight line AB, corresponding to which the projectors drawn from the horizontal trace and the vertical trace of the straight line, they happen to be 85 millimeter apart over there. Now the point of intersection of the elevation line, similarly the point of intersection of the projections of the line AB, that is small ab, in the top view projections when extended with the XY reference line will provide me with the point V over here. So we have been provided with this distance between H dash and point V measured along the XY reference line. So this distance happens to be 85 millimeter. So we have got the projectors drawn from the HT and VT of a straight line, they happen to be 85 millimeter apart. So therefore we have got H dash V equal to 85 millimeter. Similarly, we have got that the projectors which are drawn through the end points of the line. So the end points will be A dash, B dash and AB. Whenever we draw the vertical projectors through A dash, B dash or AB, so those projectors, they will be evaluated at a distance of 47 millimeter from each other measured along the XY reference line, and these points we can label as A naught, B naught. So A naught, it is the vertical projector which is going to join the points A dash and A, and we know that A dash and A points, they will be falling in one vertical projector line. Similarly, B naught, it is the point of intersection of the vertical projector with the XY reference line, and this vertical projector will be corresponding to the end B. So therefore, whenever we draw the vertical projector line which is going to join the points B dash and B, so this vertical projector line, wherever it intersects with the XY reference line, this point obtained will be called as B naught. So A naught, B naught, this horizontal distance measured along the XY reference line happens to be 47 millimeter. And besides this information, we have been provided with information regarding the horizontal trace and the vertical trace of the line. So we know that the horizontal trace of the line, it is lying 30 millimeter in front of the vertical plane, while the vertical trace of the line, it is lying 50 millimeter above the horizontal plane. So we have got HT 30 millimeter in front of VP, which will be drawn below the XY reference line, and the vertical trace, it happens to lie 50 millimeter above the horizontal plane. So this will be plotted above the XY reference line. And besides this, we have been provided with the coordinate corresponding to the end A. So we know that the end A, it is lying 10 millimeter above the horizontal plane. So the distance above the horizontal plane, it is given to us regarding the end point A of the line. So using this information available with us, we are required to draw the projections of the line AB, true length of the line AB, and the inclinations of the line true length with respect to the horizontal plane as well as the vertical plane. That is, angles theta and phi need to be evaluated. Now let us start with the projections of this oblique line. So here we have got the distance between the horizontal trace and the vertical trace projectors, that is H dash and point V. So H dash, it is the point of intersection of the elevation projection line when extended meeting with the XY reference line. This will give me the point H dash over here. Similarly, V, it is the point of intersection of the plan projection line AB when extended when it intersects with the XY reference line. So these are the 2 points H dash and V. So they are lying at a distance of 85 millimeter from each other. That is, the projectors drawn through the horizontal trace and the vertical trace of the straight line, they happen to be 85 millimeter apart. So what we can do, I can mark this point as H dash. So having marked this point as H dash, now I will be measuring a distance of 85 millimeter along the XY reference line. So once I measure this distance is equal to 85 millimeter, I will be drawing the second projector line through this particular point, that is the second point over here. So once I draw a vertical projector line after a distance of 85 millimeter from the horizontal trace location which is obtained over here. Now once I have marked this point H dash onto the XY reference line, now there is a vertical projector that we have drawn through this point H dash, and at a distance of 85 millimeter we have drawn another vertical projector line which is going to provide us the location of the vertical trace of the line. That is, horizontal trace will be located along the first vertical projector that we have drawn, whereas the vertical trace, it will be obtained along the second vertical projector that we have drawn. So point H dash will be located on the XY reference line over here, while point V will be located corresponding to the vertical trace onto the XY reference line at this particular position. So having marked the locations of the points H dash and V, now we have measured this H dash V distance is equal to 85 millimeter. Now the next thing is, we have been provided with the information regarding the horizontal trace of the line. The horizontal trace of the line lies 30 millimeter in front of the vertical plane. So in front of the vertical plane means it will be drawn below the XY reference line. Now I am going to measure this distance 30 millimeter. So H dash point I had drawn over here. Horizontal trace measurement has been provided to me. So once I mark this distance equal to 30 millimeter, I will be able to obtain the location of the point H. I will be able to obtain the horizontal trace only when from the bottom of the horizontal trace my elevation projection line will be passing, while from the top point of this horizontal trace my plan projection line will be passing over there. So I have been able to obtain one point through which my plan projection line itself or its extension, it is going to pass over there. So 2 points I have been able to obtain corresponding to the horizontal trace, since the measurement of the horizontal trace was available with me. Now second, I have been provided with the measurement of the vertical trace of the line. So in case of vertical trace, from the XY reference line my plan projection line should be passing. So this is the second point through which the plan projection line should be passing. So first point I have obtained over here, this is the second point. So I will be able to obtain a vertical trace of a line only when my plan projection line, it will be passing through the XY reference line, it will be intersecting with the XY reference line, and from the top of that vertical trace my elevation projection line itself or its extension should be passing over there. It means that this point will be point V dash. So the first point H dash I had obtained, second point V dash I have obtained, and we know that H dash, V dash, A dash and B dash, all these 4 points, they will lie along a single projector line. Similarly, points H, V, A and B, so all these 4 points, they will also be falling in a single projector line, that is onto a single straight line. So I have been able to obtain 2 points corresponding to the elevation orientation line, that is H dash and V dash I have been able to obtain. Similarly, I have been able to obtain the orientation of the plan projection line since I have evaluated the points H and V corresponding to the plan projection line. So onto this orientation of the plan projection line, points A and B will be lying. Onto this orientation of the elevation projection line, points A dash and B dash of the front view projection of this line, they will be lying onto this H dash V dash orientation line. Now another information I have with me, it is that point A and A, it is lying at a distance of 10 millimeter above the horizontal plane. So I can mark the position of the point A dash 10 millimeter above the horizontal plane. So I have marked this distance. So this locus line, this horizontal locus line I have drawn over here at a height of, at a distance of 10 millimeter from the XY reference line or the horizontal plane. Now the moment I mark this 10 millimeter, now I will be able to locate alongside this horizontal locus line the location of the point A dash onto this front view orientation line H dash V dash over here. So the orientation of the front view projection line I had already obtained by evaluating the points H dash and V dash. Now point A dash has also been located. Now the moment I am able to locate point A dash over here, so I know that points A dash and A, they will be falling in one vertical projector line only. So wherever I have been able to mark this point A dash, that is 10 millimeter above the horizontal plane. Now onto this same vertical projector line, I should be able to locate the location of the point A over here. So A dash has been located over here. So point A, it will be located alongside the orientation line HV, which is corresponding to the plan projection line. So point A or corresponding to the top view has been located over here. So point A dash has been located, point A has been located. So this point will give me the location of the point AO. This point will give me the location corresponding to this point AO. So what is this AO point? AO point, it is marked corresponding to the vertical projector line which is going to join the front view and the top view projections of the end A of the line. Now once I mark this point AO over here, I have been provided with this information that the distance between AO and BO happens to be 47 millimeter. So AO point I have been able to mark. Now alongside the XY reference line, I will be measuring the distance of 47 millimeter from this particular point AO. So wherever this particular point or the distance of 47 millimeter is located, I will be able to locate the location of the point BO over here. So what is this point BO? BO is the vertical projector line which is going to join the projections corresponding to the end B, that is B dash, and point B over here. So B dash has been located onto the H dash, A dash and V dash orientation line. Point B will be located alongside the inclination or the orientation of the HAV projection line. Now we have verified that A dash, B dash, H dash and V dash, they will be lying alongside one particular projector line which will be a straight line. Similarly, H, A, B and V. These will be the 4 points which will be lying alongside one straight line or a single projector line over here. Now, having obtained the points A dash, B dash, I have drawn the horizontal locus lines through these points. Similarly, having obtained the points A and B, the horizontal projector lines, they have been marked through the points A and B. The reason is because I have to use the method of rotation of the line. So in order to carry out these rotations, the horizontal locus lines, they will be required. Now, A dash and B dash points, they have been located. A and B points, they have been located. Now, I am going to join the plan projection line points A, B over here. This is the plan projection line, and I have been able to obtain the points A and B onto the plan projection line. Now, I can obtain the angle of inclination of this plan projection line with respect to the vertical plane. So this angle happens to be angle beta. Similarly, points A dash and B dash in the front view corresponding to the ends A and B, they have been located on the vertical plane. So I have joined the front view projection over here as A dash, B dash. So A dash, B dash gives me the front view elevation projection of this particular line. So having obtained this A dash, B dash projection, now I will be able to evaluate the orientation or inclination of this front view elevation projection A dash, B dash with respect to the horizontal plane. So this angle we are going to mark as angle alpha over here. So now the projections in the front view A dash, B dash, projections of the line in the top view AB, they have been located. Now using the method of rotation of line, now we are going to evaluate the true length of the line in the elevation and true length of the line in the plan. So I know that whenever I want to evaluate the true length of the line in the elevation, so I should obtain the apparent length of the top view parallel to the vertical plane. So this is the apparent length which is obtained in the top views. This should be brought parallel to the vertical plane. But what do I have in this case? I have got the apparent length of the line in the plan or in the top view which has been obtained onto the horizontal plane. So this is inclined with respect to the vertical plane at an angle beta. So what I will be doing, with A as the center, open compass is equal to AB length. So once with A as center, I open the compass is equal to the length AB. Now I will be marking an arc over here in such a way that this edge length corresponding to the plan projection, so this should be rotated and made parallel to the vertical plane. This is the direction of the movement of this plan projection line. So I will be rotating it through this particular distance such that this AB line is rotated such that it is brought parallel to the vertical plane. So the new point is obtained B1. Now I have been able to obtain the plan projection apparent length AB1 parallel to the vertical plane. So once my plan projection apparent length happens to be parallel to the vertical plane, now from here I am going to draw a vertical projector line upwards till it meets the horizontal locus line corresponding to the point B dash over here. So till it meets the horizontal locus line corresponding to the point B dash. So let me draw this vertical projector line. So this vertical projector line, once again, it is starting from B1. So wherever it intersects with the B dash locus line, point B1 dash will be located. So we are moving from B1 to point B1 dash over here. So this is the direction of movement of this particular line, vertical projector line. Now once we obtain this point of intersection, point B1 dash will be located. And this point B1 dash, it represents the second point corresponding to the true length of the line. So this is the projection of the second point corresponding to the line over here, which is projected as a true length in the front view. Now we are going to join the points A dash and B1 dash. So A dash, B dash, once we join, So the true length of the line we have evaluated in the front view. Now, having evaluated the true length of the line in the front view, that is A dash B1 dash, now the angle of inclination of this true length with respect to the horizontal plane we are going to evaluate. So this angle will be marked as angle theta. So once we mark angle theta over here, we can observe that angle alpha, this will be greater than angle theta, that is the apparent angle of inclination. This happens to be greater than the true angle of inclination, and the true length, it will be bigger than the apparent length of the line. So the blue line, it is bigger than the black line. So the black line A dash B dash, this is the apparent length in the front view, whereas A dash B1 dash, this is the true length of the line which is available with us in the front view. Now let us obtain the true length of the line in the top view. So in order to obtain true length of the line in the top view, I must obtain the apparent length projection of the line in the front view parallel to the horizontal plane. So this is the apparent length projection of the line which is lying parallel to the horizontal plane. But here I have got my apparent view elevation length A dash B dash. It is inclined with respect to HP at an angle of alpha. Now with A dash as center, open compass equal to A dash B dash, I will be drawing an arc such that I am going to rotate this elevation projection line A dash B dash so as to make it parallel to the horizontal plane. That is, I will be rotating it up to the locus line corresponding to the point A over here. This is the locus line corresponding to the point A dash. So once I rotate this up to the locus line of the point A dash, now I will be able to obtain point B2 dash. So the name of this point will be B2 dash, and this is the direction of rotation of the line. So this is the direction which I have marked over here. So having obtained this point B2 dash over here, now if this point is B2 dash, from here I will be drawing a vertical projector downwards onto the plan projection view over here. And up to what limit I have to draw or extend this particular vertical projector? I have to extend this vertical projector up to the locus line corresponding to the point B. So this is my point B. So corresponding to the point B, we have already drawn a horizontal locus line. So from B2 dash, we are going to draw a vertical perpendicular projector onto the horizontal locus line corresponding to the point B, which happens to be the second point of the plan projection line. So this is the plan projection line AB. So B is the second point of the plan projection line. So up to this horizontal locus line, I have drawn a vertical projector from the point B2 dash. Again, the direction of movement I have shown over here. Now once I draw a vertical projector from B2 dash onto the locus line of B, the name of the point which I am going to obtain over here, this will be B2. So point B2, that is the second point of the true length of the line in the top view, has been obtained. So once I obtain this point B2, A point, it is already available with me. So I can join points A with B2, and the moment I join AB2 with blue color, we have joined this. Now we will be able to obtain the true length of the line, and once we obtain this true length AB2 in the top view, I can evaluate the angle of inclination of the true length of the line AB2 with respect to the vertical plane. So this angle happens to be angle phi, and again we can check true length of the line in plan. This is bigger than the apparent length of the line in the plan, that is AB. So AB2, this is bigger than the AB. Second thing, apparent angle of inclination beta in the plan, it will be greater than the true angle of inclination of the true length of the line in the plan, that is with respect to the vertical plane. So beta is greater than phi and true length is greater than the apparent length. We need to validate another thing over here, that the true length of the line in elevation A dash B1 dash, this should be equal to the true length of the line in plan, that is AB2. So if we are able to obtain A dash B1 dash, that is true length of the line in elevation, equal to AB2, that is the true length of the line in the plan. So it means that whatever construction we have made till now, so this construction has been drawn appropriately. So this is an accurate construction without any error, because you cannot have two true lengths for any given line. So these two true lengths, that is one in the front view and another one in the top view, so they should be equal to each other. That is A dash B1 dash should be equal to AB2. So this way, with the given information from the traces and from the distances between the projector lines through the ends of the line, we have been able to obtain the projections of the line, the true lengths of the line in the front view as well as in the top view. And besides this, we have been able to obtain the orientations of these projections as well as the true lengths with respect to HP and VP. So this is all for today. So in the coming lectures, we'll be having more illustrative discussions regarding few more cases of projections of the oblique line. So thank you very much. Thanks a lot.